Hello everyone, happy to see you here, welcome back to my channel. Today we have a very interesting algebra question. We know that the product a times b equal to 12, and we know the sum a plus b equal to 2, and we need to find our a and b. If you have your solution, your answer, you can also write your solution down into the comment section, and then we will check our answer, so it will be really interesting. So first of all, this is a basic system of equation from school. This is algebra course right here. First of all, we need to express from the second equation. Let's express, for example, our b, and then we're gonna plug in this b to the first one, okay? As a result, what do we have? We have our b equal to 2 minus a, okay? 2 minus a. And this is extremely important expression because we have b according to our a. And right now, let's plug in, instead of this b, let's plug in to our a, 2 minus a, into like the first equation, okay? Let's do this right now. So as a result, we have a times, instead of b, we're going to plug in 2 minus a. So we have 2 minus a equal to 12. Right now, let's simplify it. We have only our one variable, so right now let's do this. Let's simplify this. First of all, let's multiply our a by parentheses. So we have 2a minus a square equal to 12. Right now, let's change an order a little bit because we prefer, this looks like a quadratic equation, yeah, but we prefer our a square on the first position, so let's do this. So we have minus a square on the first position plus 2a right here, and of course we need this 12 on the left side, so we have minus 12 equal to 0. The final tricky move, let's multiply both sides by minus 1, then we're gonna change our signs because we prefer our positive sign right here. So as a result, what do we have? We have a square minus 2a plus 12 and equal to 0. This is our basic quadratic equation. Right now, let's find it according to our basic method, method of coefficients. So we know our formula. We know that a equal to 1 from here, b equal to minus 2, and c equal to 12. Right now, let's plug in each of these coefficients into our spot. But first of all, let's find our discriminant real quick. Our discriminant is equal to b squared minus 4ac, okay, equal to. Right now, we have b squared, so we have minus 2 square minus 4 times a times 1 and times c times 12. As a result, what do we have? We have minus 2 square, we have 4 minus 4 times 12, we have 48, yeah, we have minus 48, and as a result, our discriminant is minus 44. And right now, let's plug in each of these elements into this spot because we know the formula. So a first and second equal to, we have minus b plus minus square root of discriminant, and all over we have all over 2a. And right now, as a result, what do we have? Minus, we have b equal to minus 2, so we have minus 2 plus minus square root of discriminant, square root of minus 44, and we're gonna divide it by 2a, by 2 times 1. Right now, let's simplify it. We have minus 2, so we have 2 plus minus square root of minus 44. We can write it as square root of minus 1 times 44. Let's write it like that. And right now, we divide it by 2. Okay, and the next thing we're gonna do, we're gonna write, instead of this 44, we can write 4 times 11. So it simplifies that a lot. As a result, we have 2 plus minus square root of minus 1 times 4 times 11, yeah, and we divide it by 2. Right now, according to a great math property, we can easily split it. We can write it as square root of a times b. We can write it as square root of a times square root of b. So as a result, we can easily split it like 2 plus minus, right here we have square root of minus 1 times square root of 4 and times square root of 11, and we divide by 2. So this is our square root of minus 1 equal to I, this is our square root of 4 equal to 2, so we can easily simplify this, yeah? As a result, we have 2 plus minus square root of minus 1 equal to I, square root of 4 equal to 2, and times square root of 11. We'll leave it like that because this is like a prime number, so we can find our exact value, yeah? And right now, let's divide our numerator by 2, by parts. So this part we're gonna divide by 2, so we can, looks like, split our expression in terms of real number and in terms of real part and imaginary part. So we have 2 over 2 plus minus 2i square root of 11 over 2. We can easily cancel these two. This is our 1 right here, and we can easily cancel these two from here. So our final answer is 1 plus minus I square root of 11. This is our final answer to this question. But don't forget about our substitution, because in the beginning we had, so let's write it, so but b equal to 2 minus a. So right now let's find our b. We know this is our a, so let's write a first with the positive sign, for example 1 plus I square root of 11, and let's write our a second. So a second equal to 1 minus I square root of 11. So these are our two roots, and of course right here we have two pairs of solution because we need to find our b. So from here we have that our b first is equal to 2 minus a first. Okay, as a result, what do we have? B first equal to 2 minus a first equal to this one, so we have 1 plus I square root of 11, and as a result from here we have b first equal to 2 minus 1 minus I square root of 11, and from here we have that our b first equal to, right here we have 1, so 1 minus I square root of 11. This is our b first, this is our a first, so we already have one pair. Right now let's find our b second. So b second is equal to 2 minus a second. So it looks like the same thing but with the positive sign, but let's see what will happen. Everything can happen right here. So we have b second equal to 2 minus a second 1 minus I square root of 11, and we have b second equal to 2 minus 1 plus I square root of 11, and from here we have 2 minus 1 equal to 1, so we have b second equal to 1 plus I square root of 11, and we have the second pair. Right now let's write our final answer and then we will check it real quick. Okay, let's do this right now. First of all, let's write our pairs, so our a and b. As a result, we have the first one, 1 plus I square root of 11 and 1 minus I square root of 11, and the second pair we have 1 minus I square root of 11 and 1 plus I square root of 11. So two pairs. Right now let's check it real quick and then we can say, okay, 100% correct answer. So let's prove it. Let's check it right here on the left side. So we have our question, so a plus b equal to 2 and a b equal to 12. Let's check real quick our addition, and really great moment for us because we don't need to check both pairs. We have addition, so 2 plus 3 equal to 3 plus 2, so we can easily change position, so it works only with addition and multiplication. Okay, and we have exactly that case that it helps us a lot because we don't need to check both of these. So right now let's check our addition, sorry. So we have 1 plus I square root of 11 plus 1 minus I square root of 11 need to be equal to 2. Okay, we're gonna cancel this one, we're gonna cancel this one, so we have 1 plus 1 equal to 2. Everything works perfectly in terms of like addition. Right now let's check real quick our multiplication. So we have parentheses 1 plus I square root of 11 and 1 minus I square root of 11 need to be equal to 12. Right now let's see how can we do this. A lot of students may be thinking we need to multiply parentheses by parentheses, but if you know a little bit about identities, so we have identity a square minus b square equal to a plus b times a minus b. And if you look closely at this question, so we have a, we have b, we have a, we have b, so this is exactly our case. A plus b times a minus b, we can consider it as difference of squares. So we have from here we have 1 square minus I square root of 11. We need to raise to the second power as well, need to be equal to 12. Right now we have 1 minus, we have I square times square root of 11 to the power 2 equal to only 11. But everyone knows that in terms of complex numbers, I square equal to minus 1. So as a result, right here we're gonna have 1 plus 11 equal to 12, and everything works absolutely perfectly. So our addition great, our multiplication is also is also a great thing for us. So we can either say this is our answer, but I don't have enough space right here, so my answer is right here at this part. So we have a and b equal to the first pair, and of course everything's gonna be great with the second one. You can easily check it. If you don't trust me, you can easily check the second one, but according to addition we have absolutely the same thing. You can easily see it right now. We can easily cancel this one and this one. As a result we have 2, and we can easily do this with multiplication sign because we can change these parentheses by places, and we have absolutely the same thing. So a great question. I really hope you enjoyed. I really hope you learned something new, but definitely don't feel bad if you got this wrong. You can also write your notes, write your question down into the comment section. What do you think about it? And I really hope you do enjoy it, and thank you for your time. Once more, right here we will have solution. So first of all we express b from the second one, and we plug in it to this place, to the first one. We have quadratic equation, step by step we solve it real quick, and then we move back to our substitution right here, and we have 2 pairs. Quick proof right here, so everything is great, I guess. Yeah. Oh, I really hope you enjoyed. I really hope you learned something new. This is my main goal on my YouTube channel. So wish you all the best in your life. Take care of yourself. Also write your notes, write your response. What do you think about this type of question? And wish you all the best in your life. Take care of yourself and have a great day. See you in the next videos.